In this video, I would like to go over combinations versus permutations, which is a topic in section 9.6 in our textbook. So this will be the third video that I've done in this section. Well, the main formula for combinations is this one right here, and choose R. And let me give you an example to illustrate when we use it. Let's suppose that we have 3 marbles in the bag, red, green, and blue. And the question is, in how many ways can we select 2 of those marbles? Well, we can select first red marble, followed by a green marble, or maybe it could be a green marble, followed by a blue marble, red or blue, green or red, blue or green, or first blue and then red. Now, if we don't really care the order, if red followed by green to us is the same thing as green followed by red, then we can eliminate these choices down here. And instead of having 6 possibilities here, then the answer is only 3. So when the order doesn't matter, red, green, or green, red is the same thing, then we can use combinations, the and choose R, as opposed to the permutations NPR, which is the subject of the previous video. So let me show you how this works. So in this case we have 3 marbles, so we say that n is equal to 3, and we're going to select 2 marbles at a time. We're going to let R is equal to 2, and then we do 3 choose 2. We plug it into the formula, we work it out, and we do get the 3 possible combinations that we got by listing the possibilities earlier. So these 2 are the same. Let me give you other examples. Let's say that from a group of 5 people, 2 people will be selected. In how many different ways can I select them? So 2 people from a group of 5 people. So the answer is 5 choose 2. And if we work it out, we get that the answer is 10. Now, we use 5 choose 2, and it's a combination, not a permutation, because choosing, let's say we choose Maria Tony, to us it's the same thing as choosing Tony Maria. In other words, the order doesn't matter. Now, if I had been choosing the 2 people, let's say for president versus vice president, then it wouldn't be the 5 choose 2. It would be the 5. It would be the 5 P2. Okay, I'll get back to that point in a little bit. All right, here's another example. In case there are 2 groups, one group, the first group is 5 women, the second group is 4 men, and the question is, in how many ways can you select 2 women, exactly 2 women, and 3 men? Okay, this time we're going to do 2 calculations. The first calculation is for women. From a group of 5 women, we choose 2, and from a group of 4 men, we choose 3. So we do each calculation separately and then multiply it, and the answer is 4 combinations. And if the 2 women and men and 3 men had specific positions, president, vice president, treasurer, again, it wouldn't be the choose formula, it would be the permutation formula right here. All right, I'll continue with a few other examples. Okay, here's another example. Let's say that we have a group of 4 women and 3 men, and the question is, what is the number of ways in which we can select exactly 2 women and 1 man? All right, well, exactly 2 women and 1 man would be given by the following calculation. From a group of 4 women, we choose 2 times from a group of 3 men, we choose exactly 1. And we do the 4 choose 2. We can do that in the calculator. And 3 choose 1. We can do that in the calculator, and then multiply both of these and get the answer. The second question or problem here is selecting 2 women for president and vice president, and then 1 man for treasurer. And how many ways can we select that? All right, well, then the calculations is going to change to the following. Because we are selecting these people for specific positions, it's going to be 4P2 times 3P1 permutations. And then finally, if we are just selecting 3 people randomly, then it doesn't matter whether they're men or women. Then we are going to do 4 plus 3, a total of 7 people. From a group of 7 people, we choose 3. And that is it.